All right. Hello, everybody. Welcome back. Merry Christmas or Happy Holidays, whatever you celebrate. Um, it is early in the morning here. I'm kind of tired, but it is a Christmas morning, and there's lots of snow on the ground, so it's nice. And we're leaving off where I left off in my last video, how to draw 1D terrain. You can watch that video over there. So just click over there. You can watch that. So I'm starting from the same place, and we're going to be working towards drawing it like on a texture, like a 2D texture. So it's pretty cool. But first of all, let's just go into what we need to know. So I'm going to try to take this tutorial a little bit slower rather than speed through it. I think I kind of went pretty fast my first one, so I'm going to try and really take my time to explain it. So in the first one, the last video, what we went over is we went over the x-axis, and we learned how if we just focus on this line here, we focused on how we could map this dot right here, find the left point, the right point, and then bring it through our fade and whatever, interpolate between it. And this one here too, and we found the left point by flooring this point, and then we added 1 to find this point because we're working from a scale of 0 to 1, right? So now that we're going to be drawing this in 2D, or yeah, I'm going to in 2D, what we need to do is we need to incorporate in the y-axis now. So let's say, for example, I want to find the value of this pixel right here. What'll happen is I'll go through the same thing I did the first time here. I'll floor this x value, so I'll get this x position here, which in this case is 1. And then I'll floor also the y value. So in that case, right now it's 1. Now some things we need to know is also not just the top left point and the top right point, but also the bottom left point and the bottom right point. So how we do that, if you think about it, is this right point here is if we add 1 to our x, we get that point. So this is going to be x plus 1, x being this this top left point's value here. So let's call this ix, and let's call this iy, like index x and index y. So this is going to be index x plus 1 and index y. And that's going to be this point here. We can use that to find this point. And then the bottom left point is going to be ix, but then iy plus 1, like that. And then the bottom right point is going to be ix plus 1 and iy plus 1, like that. That should make sense. So if we floor the values here, and we get 1 1 here for ix and iy, and then we're adding 1 to different variables here to find these points. By the time my pixel moves down over here to this one, this corner, and let's say now I want to floor this value. So I'll floor the value, and what I'll get here for the x value is 2. So I'll get an x value of the top left corner, same thing, of 2, and for the y value, I'll also get a value of 2, which is the same value I get for this point when I find the pixel of this one. Because right now it's 1, ix is 1, and iy is 1. I'm adding 1, so I'm getting 1 and 1 is 2, and 1 and 1 is 2. So 2, 2, and when I move down here, I also get 2, 2, which is great because now we can find this point regardless of what position we're in. If I'm over here, it's going to be the same thing. If I'm over here, this point is going to be the same. Right? If I'm right here, I'm going to floor the x, it's going to be 1. This point right here it's going to be 1. And then the y is going to be 2. And then this position over here is going to be ix plus 1 iy. Ix, that's going to give us 2 and 2. So regardless of where we're at, this point is going to be the same. So we can find it using this kind of technique here. Okay? Let me just clear everything off my screen. I hope that makes sense. We just need to find a way to reference the 4 points, the 4 corners of our screen, so to speak, as we start moving forward. Start moving down our screen and mapping stuff. Okay, so one other problem, or thing that we need to incorporate here, is we need to find a way to use these positions, to use this 2, 2, right, to get a unique random number that we give this point, right? We need to find the value of this point using these coordinates. So we need to convert coordinates into a unique point, or into a unique, value, but then we need to make sure that there isn't any other coordinates that can give us the same seed or give us that same value, so it doesn't repeat, right? So this actually poses kind of a problem, because let's say, for example, this point over here is 3, 1, right? And so I pass this through. Let's say I find the seed. I use a random number generator with a seed of 3, and I get 1,000, right? And then I also use the y value there to get that seed, or get that random number generator, whatever, and I get a value of 500, we'll say, right? And now I add these together and I get 1,500, and that's going to be my final seed. So I run that through a number generator, and I find this value of 0.7. Okay, cool. So it works. We use the x and we use the y, and we got ourselves a random value for that point. But the problem is if we go down here to this point down here, which is 1, 3, we're going to have the same value, because the 1 is going to get passed through as that seed, and we're going to get 500, and then the 3 is going to get passed through, we're going to get 1,000, and we're going to use that then and add it if you want, and we'll get 0.7. And that's not okay, because we're going to be mirroring it then down like this diagonally, because the x's and the y's are going to be the same. Right, so what we have to do is we have to make a function where when I pass through an x and I pass through the y, it gives us a unique number, right? But if I switch these two around, I make this yx, it gives me a unique number as well. I need to be able to flip the two around and have it give me a unique number, right? So it doesn't mirror itself. So what we're going to do that is we're going to blow the x scale here, the x x-axis, there we go, out of proportion, right? We could multiply this first value here by like 9,999. And that would work, because y would never equal 9,999, at least not for a very long time, but eventually it would repeat. So what I would do here is, if I multiply this first position by 9,999, then that would be a temporary solution to our problem, right? Because I go over here to 3, 1, but my 3 is multiplied by 9,999, so that's like some really huge arbitrary value. And then down here, though, I multiply my x, which is 1, 3. So this right here is 9,999 and 3. So it's not giving me the same number. It's not giving me that. But the problem is eventually it would repeat along the y-axis, because eventually if I went down far enough with x equals 1, and I go down far enough with my y, I'm going to eventually repeat. My y is eventually going to equal 9,999. So I don't want it to repeat at all. So the solution that we're going to do is we're going to make x negative. So negative x, y. This is what we're going to give into our function that gives us a random seed back, so we can find the values of our points. I hope this makes sense. You'll kind of see how this works once we actually get coding. So let's go to Gamemaker, where I still have the same setup here that we left off with, and let's just jump into our master noise function. So the first thing we need to pass in, as well as our x position, is our y position, because we just have our x position right now. So get some coffee. It's okay. We're going to pass in our y position, and this is going to be argument 1. And I'm going to change my other arguments here, 2 and 3. Cool. So we have our y position. We're going to need to pass that into our noise function, just like we did our x position. Let's go y position and multiply that by frequency as well. If I didn't multiply this by frequency, or I changed this, I could change the scale of my texture. So I can make it squashed on the y, or stretched along the y, or squashed on the x, stretched along the y, or whatever you want to do. I'm manipulating the ratio there of the x position to y position. So if you want to play around with that, you sure can, but I'm not. Okay, so we're going to pass in our y position there to our frequency. That's pretty much it for our master noise function. And now we'll jump into the actual function here that gives us values. So right now we are interpolating just along the x-axis. So I find the value of this point here, I get the left point, I get the right point, and then I interpolate, that's the value. All right, now what I need to do though is we're going to have to go through a couple more interpolations. So I do want to find the I do want to interpolate between the x and the y, this top left and the top right. I also want to interpolate between the bottom left and the bottom right to give me this point. And then I want to interpolate between this point and this value using the y position of that point, right? So we're kind of rotating it like this, and we're doing it again. We're interpolating again. So I'm actually going to delete all this, and we're going to backpedal here to our seed, finding our random seed. So the first thing we're going to need to do is to make a seed function. So I'm just going to call this get seed, and this is going to return us a random seed based off of 2 inputs, and if I flip the inputs, it gives me a completely random seed again. So what we're going to do is we're going to have val1. It's going to load that in here as argument 0, and value 2 as argument 1. Okay, so we have our values. Now let's do some stuff. So I'm going to go random set seed, and I want to set my seed to value 1. Now remember how I mentioned before, we're going to make this negative, just like that. And then I want to go first seed. It's going to be random, and then just a very, very large number like that. And then we're going to set our seed again to our second value, and we're going to get a second seed, just like that. Now what we're going to return is we're going to return our first seed plus our second seed, and we're going to add in our constant seed that we create here when we first start our room. That gives us a random texture or a random whatever. It kind of changes it up so it's not the same every time. So this is our get seed. So when we pass in here a value of 1, or let's say 3 1, it's going to go -3 1, and it's going to find those 2 random values based off those numbers, and we're going to add them together. Okay, and when I flip them around, we're going to get a value of -3 1, and this -3 is going to return a different value than 3. So it's going to be unique even if we flip the inputs, and that's really important. So now that we have a random seed generator, we can jump back over here to our noise function where we can actually do some stuff. So the first thing we need to do is we need to load in our y position like that, and we're already flooring the x, and we're flooring the y, or flooring the x, and we're finding the top left and the top right points. We're finding those points, but we need to find the bottom left and the bottom right, and the y position, so to speak. So we're going to go y minimum equals floor y position, and y maximum is going to be a y minimum plus 1. Okay, so we're doing the same thing for the y that we are for the x. We're finding our y position by flooring it there, and we're finding our x position by flooring it there, right? So now we have our coordinates of our top left point, so to speak. Okay, so what we need to do now is we're going to find a random value of that top left point, right? So we're going to go random, set seed, get seed, and I want to do x minimum, y minimum. Okay, so these are just we're loading in the coordinates, right? We're not adding anything to the coordinates. So if I'm finding the value point of this right here, this is going to be along the x, it's going to be 2. So the x is going to be 2, and the y is going to be 1. And we're just loading these numbers into our get seed as coordinates, right? X, y, and it's giving us a random seed back that we're going to use then as our seed, and we're going to find that point's random value. So I'm going to say corner 0. It's going to be the top left. Corner 1 is going to be top right. Corner 2 is bottom left. Corner 3 is bottom right. Those are going to be my variable naming schemes. Okay, so corner 0, I'm going to go random range, -1 to 1. Now we're going to do the same thing for our top right point. Now for this one, it's going to be x minimum plus 1, because we're adding 1 to our x. We're going over here 1. And the reason that adding 1 works in this case is because we're working on a scale of 0 to 1. Right? If I were to be using incorporating frequency into this, it wouldn't work this easy, right? That's why we're using a scale of 0 to 1 to make it easy. So just like that, and then corner 1 equals random range -1 to 1. We can literally just copy and paste this a couple times, make it easier for ourselves. Like that, corner 1, corner 2, corner 3. So corner 2 is going to be 0, 1, 2. It's going to be our bottom left. So that is going to, we're going to keep the x value and we're going to add on to the y. It's going to be down 1. And the last corner here, we're going to add 1 to both the x and the y. Oh, plus 1. There we go. Okay, so we have our corner values, right? We have corner 0, 1, 2, and 3. So that's it. That's all we have to do there. Good job. You made it this far. I hope I'm explaining this okay and you're understanding what we're doing. Now we have to interpolate between them. Yeah, sometimes when I say interpolate, I say interpretate or I don't know. I have a hard time saying it sometimes. It's weird. English is hard. So, okay, the first thing we need to do is do our first interpolation between these 2 points, and then do a second interpolation between these 2 points, and then interpolate those two together right there. Okay, so we're going to do our first interpolation here, so we're not going to return anything yet. And I'm going to call this lerp1. It's going to equal, and then we're not doing left point and right point, right? We're doing corner 0 and corner 1. And then x position minus x minimum. That works. Okay, so this is our first interpolation there. Let's go do our second now. Calls lerp2. And this is going to be between corner 2 and corner 3. Corner 2 and corner 3. And now we're going to interpolate between these two values, and that's what we can return. Return between lerp1, lerp2, except now we need to use our y position right here, not our x position. Okay, so we're going to do y position minus y minimum. And that should give us the answer we're looking for. This right now should be it. This should work, okay? It's that easy. Let's jump. We have to draw it now, right? So we're going to change some stuff here. So that's going to be the end of our actual coding our function, right? Now we're just going to work on drawing stuff. So we're going to jump into our draw event. We're no longer drawing a line, so we can remove that. We don't need our YY previous or YY, and we don't need that. We need to pass in our Y position. So Y, I'm going to multiply that by the same number, 0.001. Okay. And we're not multiplying it by amplitude because we're no longer drawing it as a line, the value we get back. We're drawing it as a color value. Right, we're wanting to do this as like a texture, so it's a color value. So what I need to do is I need to make a color, but first let me just remove amplitude here. Let me remove YY, and let's jump back over here. Okay, so I'm just going to say value is going to equal what we get back, our noise. Okay, so let's make a custom color. This is going to be the color, whatever that. I always forget the it's a color make HSV. Yeah, make color HSV. There we go. Okay, so we're just looking to do a black and white scale. So we're just going to go 0, 0 for our saturation, and then our value is going to be val. Right now, if you know anything about the colors, but I know you do, but I'm going to go over it anyways. It uses a range of 0 to 255 is how making these color things work. So our noise function here, though, is giving us a value between -1 and 1. So this is a problem, right? We have to kind of move it up to 0 to 255. So how we're going to do that is we're going to take what we get back and multiply it by 127, like this. Go, and then we're going to add 128. So why do we make this 127 and not 128? Well, because if we get back 1, if our noise function here returns the value 1, and we multiply it by 128, that's going to give us 128, and we're going to add 128. That gives us 256. That's above 255. So I'd rather limit it to 254 than go over 255. So I'm limiting it between 1 and 254. Okay, that's my range here for this function. So my value is now going to equal somewhere between there. So this color now works. This is an actual color that we can see and use. So now we need to draw a rectangle color, and we need to choose our x and y coordinates. So we're going to go x, y, x plus 1, y plus 1, and then our color is going to be our color, and then an outline. We do not want it to be an outline. We want to actually fill it in. Cool. So this is throwing me an error. Oh, I forgot the comma. There we go. Okay, so we're also going, we need to change some other code here. So while x is less than room width, we want that, that's fine. But I want to say as well, if y is less than room height. So if it's less than room height, I want to do this. We need to set our target in here like this. Let's make this look pretty. Make this look readable. There we go. Okay, so it's if our y position is less than our room height, we're going to draw a line, and we want to, once that's done, increase y by 1. So we're going to go y plus plus, and we also want to set our x back to 0, so we can draw our next line, draw our next line, draw our next line, and it keeps going until it's filled the screen. Okay. Awesome. So, okay, this is working great. I gotta think about what else I need to do now. I don't know. Let's give it a shot. Let's see what we have. It's probably gonna be absolutely terrible, or it might just work. Okay, look at that. It's actually working. Perfect. Okay, but there's some problems. There's some clipping going on. Okay, let me back that up here. X equals 0. I never set my y to 0. I need to set my y position to 0 so it draws it. And just for this scenario, I'm just going to set my octaves back to 1 so we can just see pure one value noise, right? We're not adding octaves on top of it. I do think I changed my room size actually since the last video, so we can bring this back. Let's just like make it 800. Make it 800 by 800, so you can see it a little better. Let's see. There we go. Okay. Yeah. It is drawing value noise for us. How cool is that? Do the value noise jig. Yeah. Okay, we don't need to watch it any further. Okay. Sweet. Okay, now there's a problem though. Let's jump back in here, and you saw it earlier. Let's bump this back up to 6. Let's see if it'll happen. So it is adding the octaves on top of each other right now. It is adding the color values on top of each other. And what should happen, it's not going to do it for us, is it? Let me try again. Of course it doesn't want to. There, okay, right here. You can see it's clipping. You can see it's past the white value. It's past our 255 value, and it's jumping back down to black, right? And in the black areas, if it goes beneath 0, it's going to go up to white. There we go. See right there. Okay, now you can't see my hand. My position on the screen is different from your guys's point of view. Okay, so what's going on here and why it's doing this? Let me just jump to a blank page here. Okay, let's see here. So on my first octave, I'm just going to call this Oc1. What's happening, theoretically, is we can return a value of 1. Right, we return a value of 1. On our second octave, it can, because we split our amplitude in half, it can potentially return a value of 0.5. Okay, this is a problem, because when we add these two together, we can return a value of 1.5. Now, if I take this right here and I multiply it by 127 and add 128, I map it between the value of 255, I'm going to get something completely higher than 255, right? So what I need to do is I need to find the maximum value that this can be. So in this case, the maximum value my first octave can be is 1, and the maximum value my second octave can be is 0.5. At the very end here, before I return it, I want to divide it by my max value, right? So in this scenario, it's giving me the maximum value, and I want to find the maximum value and put it and divide it by that. So this is going to give me 1, right? If I can theoretically find my max value. So let's do that, and that's going to make sure that we don't ever pass 1. Okay, so we'll go into our noise, our master noise here, right, where we return our noise function, and let's make a variable called max value, and we're just going to set that equal to 0 to start. Now, our maximum value is amplitude. Our amplitude is the maximum value it can be. So when we multiply this noise function here, which returns a value of -1 to 1, and we multiply it by amplitude, amplitude is the highest it can be. So starting off on our first octave, amplitude is 1. So what we're going to do is we want to add max value plus amplitude. Oop, that's not a var. Okay. So every time for every octave, we're adding amplitude to our max value. So our max value at the end of our octaves should be equal to the maximum value that we can return. So what we need to do then is put result over max value. And that should limit it for us, and we should no longer get any kind of clipping or anything like that going on. Let's see if it works. And it does. I mean, I know it's going to work, but I mean, I just wanted to show you guys. So it's a pretty performance intensive thing. Now what might help is increasing your room speed. Just set that to like 9,000 whatever. It runs a little faster, at least for computers, for my computer. Or not, never mind. It doesn't run faster at all. It does not run faster at all. For every octave you do, it takes that much more time. There's like something like if you're running in like a 1280 by 720 room, whatever, there's like 6.5. It runs through this function like 6.5 million times to find your texture. So it's very, very intensive. One thing, a little trick for you, right? This is a trick. Instead of our noise function here, instead of using floor, there's actually a bit shift operator that you can use that's actually faster. And it is 2 squiggly things. If you put 2 squiggly things in front of this variable, it floors it, but it's actually much faster than using the floor. Ooh, I'm hiding myself. Oops. Didn't know that hotkey was there. Anyways, if you use that squiggly thing, it's actually faster than using the floor function, and it does the exact same thing. Right? I don't really know why, but it just is. I actually tested it. Using the floor function. I ran it like something like 99 million times. It took like 10 seconds, and when I did this 99 million times, it took like 7 seconds. So it's actually about 25% faster, which is pretty good. So for something like this, it matters. The speed matters, because you're running the calculations so many times. So you're probably not going to notice a difference, but when you just do little tricks like that, it eventually adds up, and you can do it a little faster. So that is it, guys. We just made value noise. That's all it is. I hope you guys learned something. If you have any questions, let me know, I guess. Take another sip of coffee. My next tutorial coming out will be on Perlin noise. We're making 1D Perlin noise, which is different, but very, very similar. It's the same structure as this. We're using the same structure, just different calculations to find our values for our corners. So I love Perlin noise. It's so much fun. So All right, take care, guys. We'll see you later.